So Indy racing, always very exciting. With the wheels out on the side, very dangerous. But we also want to see people pushing the cars faster and faster and faster. I mean, you can only pay attention so perfectly. But guess who can make decisions faster than humans? Machines. A lot faster. That's why we're here at the Indy Autonomous Race Challenge today, because some of the world's best engineers are competing to see how smart they can make the decision-making skills of these Indy cars. We're gonna learn about what kind of hardware is actually now sitting in the cockpit, what has replaced the actual driver that makes these cars run autonomously.
Have you ever scraped the wall?
Not yet, knock on wood.
So before heading off to the races, let's start with a quick pit stop to cover the basics of autonomous race cars. So these are a class of self-driving cars that have their software optimized for aggressive driving. And this includes passing at top speeds, split-second braking maneuvers, and pushing the physical limits of the construction. Now, Indy cars are one of the most iconic types of race cars. Now, they feature a 2.2-liter twin turbocharged direct-injected V6 engine optimized to run at a jaw-clenching 12,000 RPM and top out at over 700 horsepower. And guess what? These Indy cars will be fully autonomous. Now, the cockpit will be completely replaced with sensors so it can observe its environment. Actuators will control the wheels and pedals, and the software is going to make all of its own autonomous decisions. Now, during the race, these cars will not be remotely controlled by humans. So all the decisions have to be made by the pre-configured software. And that's where the competition really kicks in. Now, the software is either hand-coded or it's trained on data by the individual teams. So the teams of engineers are competing to make the brains of the car smarter, faster, and better. So that means it's a coding and AI training competition at the end of the day. And the best code will be judged out there on the racetrack based on what autonomous decisions these Indy cars make on their own.
All right, so we're here at CES 2022. See where the state of the art is. Let's do it.
Let's do it.
So we are going to actually be seeing these racing at full speed today. How cool is that? I've definitely been surprised to see how many competitors to Tesla it seems like there could be. You know, I believe it's all about the software. Absolutely impressed with how many electric cars are quickly coming onto the market. The 10.8 beta for self-driving was just downloaded. As long as we're watching autonomous race cars, why don't we also check out the state of the art in autonomous driving? Let's see how it does. So I'm just gonna take over here. Charge, nope, it yielded. Whoa, no, that's not a lane. Here we go. The racetrack is right above us. So we are headed to the middle of the racetrack, actually.
Nice car. You can tell, not totally confident in where the position on the track. Race control.
The great thing about autonomy is we can have packages going at much faster speeds than a human would be capable of. So things that don't have to be alive like us, they can go at extreme speeds in many different facets of the future.
We tried obstacle avoidance, improving that, which worked really perfectly today. I'm going to challenge the winner of the Indy 500 for a head-to-head race and see what happens.
My goodness, the gauntlet has been thrown down, and what a huge statement that is about the confidence in this technology and the future it has.
So today was a super exciting day, but it wasn't without its costs. So I'm glad there were no humans that were hurt, but millions of dollars certainly did disappear. These cars are making the decisions, and it just hammered home the concept that these cars in the future are going to be able to make split-second decisions at super high speeds. Complex decision making is getting so much more advanced. It's exciting to see, and it's exciting to imagine what the future is going to bring.
So now let's look at some of the key hardware that's used to transform these race cars into robo-racers. Now the first is called LiDAR, which stands for light detection and ranging, which is a remote sensing technique that uses light in the form of pulsed laser. So this works by targeting objects around the car with laser light and measuring the time for that reflected light to return. From there, an onboard computer can compute the reflection distance to generate a three-dimensional map of its environment moment by moment. Now the second class of hardware is simply radar. Now because radio waves are actually the light spectrum, just a different part of it, these might seem surprisingly similar. But they're not exactly redundant, because LiDAR is using a shorter wavelength, which means it sees more detail. But even though radar has a bigger wavelength, it still can sometimes penetrate different types of materials. And it simply returns different information about the environment, and the computer can learn from both signals. And finally, there are cameras. Now, I would imagine that computer vision is the meat and potatoes of these cars' decision-making cues. Now, I only say this because I know that Tesla is starting to dial back their radar and LiDAR systems and focus more on their camera vision systems. In fact, Tesla's head of self-driving, Andrew Karpathy, said, quote, "We deleted the radar and we're driving on vision alone in these cars, and that was way back in 2019. But who knows, maybe in a race car setting, some other combination of technologies work better." And that's exactly the goal of these kind of competitions, to try to push the hardware and software to its physical limits. And to be frank, there have been Teslas out in the wild that have been photographed with LiDAR systems on top of them, so they must be using that data to at least augment their computer vision. Now, from the software side, the entire racetrack is outfitted with a very high-speed 5G wireless connection. And that's for cloud computation, data collection, and asynchronous communication. Basically, the software used for running these cars, like connections to the pedals and the steering wheel, and that information is actually stored in a shared GitHub for all of the teams to use. And that makes a lot of sense, because you want the competition to be like a human driver who can actually race car drive the best. And there's also a shared simulator used for fine-tuning their model. So before you put these race cars out on the track, you put them in a simulated race car on a simulated track. Now, the history of autonomous cars is obviously a very deep topic, so I'll keep these milestones to high-speed team challenges. So let's start with the most dangerous and unreliable self-driving car that has ever been built, by Carnegie Mellon University's Nav Lab in the 1980s. Now, this was a team of ragtag people who would never settle on the status quo. But now, 16 years later, in 1996, lamestream by-the-book engineers at Argo got a driverless car to follow a painted line on a highway. But real team-oriented competition didn't get going until the government got involved. Now, it all started with a series of 3 internal military challenges, where teams of engineers competed to provide navigational capabilities to unmanned supply vehicles, and this started a pattern of progress and discovery. In fact, the strategy proved to be so successful that in March of 2004, DARPA, the Defense Advanced Research Projects Agency, created the first DARPA Grand Challenge. Now, this was an open-to-anyone competition that offered a $1 million cash prize to any team of robotics engineers that could make a car drive 150 miles in the desert without any help. And guess what? No team actually completed the challenge the first year. But to say it was a failure would be a huge misunderstanding of how far the technology was actually pushed that year. It set the stage for the following year, where a team of engineers from Stanford with a car named Stanley actually won the competition. And because it was so successful, since then there's been all sorts of military challenges along the same lines. For example, fully autonomous border patrol cars, submarines, and unmanned combat air vehicles have kept pushing the state-of-the-art forward. In fact, fairly recently, in August of 2020, humans lost air-to-air combat dogfights to autonomous airplanes 5-0. So I would say that these AI-based F-16 jet fighters signal the possible end of the human fighter pilot altogether. And I suspect this is just the beginning of how far autonomous software can push real-world speed records. So if you enjoyed this content and want to help me continue making cool future technology-based topics, please hit subscribe, press the bell notification, leave a comment below. All of that stuff really helps me. We're still under 1,000 subscribers. It's slow growth, it's killing me, but I know how exponentials work, so I'm in it for the long run. But I would certainly appreciate it if you could hit that button for me, and I'll continue trying my best to bring you awesome content.